Hello and welcome to our physics video. Today we are going to discuss how Newton's three laws relate to three sports: tennis, volleyball, and swimming.
Newton's first law: every object in a state of rest or of motion in a straight line at a constant speed, unless it is compelled to change that state by forces exerted upon it. Simplified: objects will stay at rest unless an unbalanced force is exerted upon it.
Newton's second law: the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. Simplified: for every force there's an acceleration and a mass to go with it.
Newton's third law: whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Simplified: forces on an object are matched by equal and opposite forces.
The way that swimming is affected by Newton's second law is that in swimming, the more you push on the water, the faster you go. In swimming, the force produced by the swimmer is equal to the mass of the swimmer multiplied by the acceleration of the swimmer in the water. Basically, more force equals more acceleration. The way Newton's third law affects swimming is that when you do a stroke in the water, you push your arm down, and the water pushes you up and propels you forward.
Volleyball players who miss a serve, hit a ball into the net, or block a ball will feel the effects of Newton's first law. The server's hand, the net, and the hands of the blocker act as the unbalanced force which stops or changes the direction of the ball, which is the object in motion. The action force of a spiked ball meets the reaction force of the player's block. Another example is when a team scores a point. The action force of the hit ball meeting the reaction force of the opposite court displays Newton's third law. The floor returns with more force than the ball, so it will bounce off the court to equalize the reaction of the impact.
Newton's first law: if an outside force was not projected on a tennis ball, it would stay in rest forever. However, when playing a tennis game, the racket acts as the external force pushing the ball into motion. Tennis players will put topspin or underspin on the ball so it will land in the court. This friction from the ground plus any air resistance stops the ball's motion, that is, until the other team hits it back. Newton's second law: the mass of a tennis ball is constant. Since the force exerted equals the mass times the acceleration of the ball, the acceleration is directly proportional to the force applied. Therefore, the harder the hit of the ball, the faster it will go. Tennis players use strategies like hitting the ball on a certain section of a racket to succeed this harder hit. Newton's third law: when a tennis ball is hit against the surface of the court, the same force the ball exerts on the ground is exerted on the tennis ball. The same is for when the tennis racket hits the ball. The ball exerts just as much force on the racket as the racket does the ball. Thus, tennis players often apply shock absorbers to their racket so there is less recoil. After all, the ball's force affects the player's whole body.
Why are Newton's laws essential for all movement?
Newton's laws are important because they are the foundation of mechanics, the study of how objects move or do not move when forces act upon them. These laws tell us exactly how things move or stay still, like why you don't float off the couch or fall through the floor of your house. Newton's laws control how vehicles work, how buildings don't collapse, how water flows, and generally how everything around us moves.
How does friction relate to Newton's three laws?
For example, for a car to move, there must be friction between the wheels and the ground. The wheels exert a force on the ground because they are spinning, and the ground exerts a reaction force on the wheels. It is this force which pushes the car forward. Because of the friction, the car was able to move. This can also be seen in countless daily activities like walking or running.
I see us forces acting all around us. You can feel them pushing,
Measured in newtons.
You can feel the pulling down your spine. forces, accelerating objects. They can move inertia,
Swinging left and right.
they can change your speed, always coming at you. Try to stay in line.
We're action and reaction. We're opposite direction. We cause acceleration. Some people call us friction.
You will find apples fall down from trees.
All I see are forces. Tennis players use them. Shock absorbers tame them. Swimmers also use them. They just stroke and glide.
Serve set spike and blockade, applying different pressures. Sometimes there's no returning. Their masses may not matter. We're action and reaction. We're opposite direction. We cause acceleration. Some people call us friction. Some people call us friction.
Newton's laws are right. Yeah. Newton's laws are right. Yeah. Newton's